Good day everyone! Today we're going to prove the following assertion. So for number 1, let x is an element of z. So if x is an even integer, then x squared minus 6x plus 5 is odd. So we need to prove it by using direct proof. We need to prove this. So first is we write the word proof, and then we assume that x is an even integer. Then x is 2a, indicating that it is an even integer. For sum, a is an element of z. So then, we need to substitute the value of x with 2a. So here's the result. And then this. So we need to break down this 5 so that we can factor out the common of this by leaving the plus 1. So we remove the common factor, which is 2. So equals to 2b plus 1, where b is 2a squared minus 6a plus 2, an integer since a is an element of z. As a conclusion, therefore, x squared minus 6x plus 5 is odd. Don't forget to put this symbol, which is called quod erat demonstratum. So for number 2, 5 to the power of n minus 1 is divisible by 4 for all integers and is greater than or equal to 1. We need to prove this by using the principle of mathematical induction. So proof, let Pn be the formula for divides 5 to the power of n minus 1. So we need to prove that Pn is true when n equals 1. So the P1 is 4 divides 5 to the power of 1 minus 1, which is true since 4 divides 5 minus 1 is just equal to 4 divides 4. So that is true. So next is assume that Pn is true when the value of n is k. Then 4 divides 5k minus 1. Hence, 5k minus 1 equals 4m since 5n minus 1 is divisible by 4. So our m is an element of this. So next is to prove that Pn is also true when the value of n is k plus 1. Then 5k plus 1 minus 1. So we need to distribute it. 5k times 5 minus 1. We need to break down 5. So just equal to 4 plus 1. And then in this case, we need to put 4 at the beginning and multiply by 5k plus 5k minus 1 so that we can substitute this equation to 4m. So 4 times 5k plus 4m. Now, let us get the common factor, which is 4. So 4, the parenthesis of 5k plus m. So 4p, just the result, where p is 5k plus m, an integer since m is an element of z, or the set of all integers. Therefore, we conclude that by principle of mathematical induction, the formula holds for all integers and is greater than or equal to 1 is true. So thank you everyone. So I hope you learned something from my performance or video.